This video looks at MATLAB tools for doing behavior analysis and step responses. Behaviours then underpin a first course in control, and we want to be able to analyse and quantify these. Defining behaviours by hand is tedious, so here we show how MATLAB can be used to improve efficiency, basically make it easier. And step responses are a key part of behaviours, so we put some special focus on those. You'll notice if you want more detailed notes, please look in section 2.6 and chapter 3, which you'll find are both around here. Behaviours then link to the poles of a Laplace transform. So a transform represents a signal, but typically the dominant poles in behaviours come from the system model. So here you'll see I've got a model and then I've got an input signal. And the behaviours of the output transform, you'll see the behaviours are here. You'll see the first two, these two, come from the model, and the last one comes from the input signal. Now, step responses are the most common type of behaviour. So that's the input given by something like 1 over s. Now, it could be a over s, but generally we'll use 1 for simplicity. And step.m is the main MATLAB function that deals with this. So we're going to illustrate that. So what MATLAB files have we got then to support behaviour analysis? And we're going to assume, as ever, you've downloaded the apps and live scripts from section 6.8 and 6.9. And we're going to focus on these two live scripts here. So transfer functions and poles and behaviours, and step responses with MATLAB. There is a shorter, more focused file, tutorial week 8. And also what you'll find is all of the apps and the GUIs in chapter 6 implicitly investigate system behaviours. So you may want to look at the resources there and open some of those. Now, a reminder, the purpose of this video is not to teach MATLAB, but to rather illustrate quickly where appropriate code is provided so that you can self-learn how to use MATLAB and experiment yourself so that you can reinforce what's going on. So let's go to the files then. So first we start with this one, transfer functions, poles and behaviours. Now you'll see section 1 basically goes through how do you create a transfer function in MATLAB, and you'll see this line 1 gives an illustration. You use this function tf, and basically there's an example above and it shows you what code would give you that example. There's an example below, G2, and an example below, G3. So hopefully those 3 examples are enough for you to get an idea for how TF might work. And as ever, you can easily modify these yourself. I could even create a new one here. I could go G4 equals TF 1, 3, 4, 5, just like that. Run section, and there you see G4 has appeared on the right hand side. So you can experiment with this yourself. What about computing poles and zeros from a transfer function? So if you've already got a transfer function, how might you find the poles and zeros? Well, the key file is this file pzmap, p for poles, z for zeros, and map. Can I map them out? And you'll see you can either do that by getting the values. You can see here are the values, the poles, the zeros, okay, for those different examples. Or you can produce a picture. Crosses for poles and zeros for zeros. So again, you'll see the code there in section 2 shows how you might do that. What about steady states and step responses? Well, you can just plot a figure if you want. Impulse does the inverse Laplace of a signal, and step basically multiplies by 1 over s. And so you'll see the code here shows you how you can use those and create some figures. So you can see the top figure, signal z and y, so that's basically doing the inverse Laplace, assuming that z and y are a signal. And then this one here does the step response, assuming that z and y are transfer functions. Okay, a bit of code down here to actually extract the steady states, okay, and you can see the answers are given here on the right hand side. So again, you've got the exemplar code, so you can play with that and put in your own examples. General, you might want to characterize how systems behave, and step's quite useful for that. So section 4 looks at characterization and shows you the basic skills, and you'll see here we're creating a transfer function given the poles. So there's the poles, Then we create the transfer function, and then we show the PZ map, there's the figure there, and we show the step response at the bottom. What about step responses then? So we want a particular focus on step responses because they're very useful. So section 1 shows the basic use of step. If you just go step G, it will multiply this transfer function by 1/s, do the inverse Laplace, and create a figure. There it is. So you can play around and obviously, as ever, change this code to suit your specific needs. However, MATLAB will give the end time for the step response that it thinks is most appropriate. What if you want to control that? We'll see here line 14 shows you how you can control that. At the moment, end time is set at 1.2. Well, I can change that 1.2. I could make it, for example, just 1. So now if I run the section, okay, and now you'll see the end time is changed to 1. So you can control that. What about if you want the numerical values of the step response for lots of different time instants? Okay, so you'll see here line 25 shows you how you would do that, and you'll see the values are listed here on the right, and you can see there's 101 values here because I've basically let MATLAB decide. I've stuck in an end time and said, you tell me how many times you're going to do it. Okay. And you'll see there's a second example down here. So again, you can play with this and decide for yourself what numbers you want to put in. What if you want to overlay the responses of several different systems on the same figure? So you'll see section 4 shows you how to overlay, and you'll notice the key command is line 46 here, which shows you overlaying the step responses of 3 different transfer functions. And if you want to control the end time, you can see there it is. Line 52 gives an example where you're controlling the end time. Now, what if you want to create figures for reports? So now you actually want to control yourself what the figure looks like rather than letting MATLAB just throw out a default. So the key point here is you need to calculate the values using steps. So you'll see lines 58 to 60 show you how you can calculate the values. You'll see they're actually listed on the right, but the key thing is I'm calculating them, and then I use the plot statement directly, because if I use the plot statement directly, I can control colors, line styles, font sizes, and anything I want. And finally, section 6 looks at what if the input isn't 1? What if it's 3.6 or something different? So, some conclusions. We've demonstrated MATLAB files which allow students to develop an understanding of how to analyze and quantify system behaviors and responses. The files are not intended to be comprehensive, so obviously if you want more fine detail, look at section 6 and chapter.